Hello and welcome to Solving Trig Equations Graphically Part 2. I've got my second example. It doesn't have a context, but it's a trig equation, and we're just going to go ahead and we're going to solve it using the graphing calculator. Certainly could be solved using some algebra, but I'm going to use the graphing calculator. So how do we do it? Well, again, I look at this thing, and I think it's easier if you just make one side equal to 0. So what I'm going to do is I'm going to move the 2 over to the left side. That looks like the least amount of trouble, and it makes it equal to 0. Now, things are kind of spun around here, but essentially this is the function that I would like to type in. Now, usually we see it written as y equals. Looks a little funny when you got it, this way. So I'm going to spin it around and make it look respectable, but I'm still going to try and graph it and find the x-intercepts. That's still going to be my strategy here. Now, I picked this example because a lot of students are not sure how do you put in sine squared into the calculator. And really the trick is to do this. You have to put in a bracket, and then close the bracket, and all of that is squared, and then inside the bracket, see, you're going to have something that looks like this. So there's a lot of brackets going on, but inside you have your sine x with a bracket around the x, and then the brackets that tell you that's the whole thing that's being squared. So that's the trick to how to put it into the graphing calculator. So let's pull up the graphing calculator. And you can see here, it's moved off the screen a little bit, but I'll show you what I've typed in here. So you can see, there it is. I got my 2, my sine x, but there's brackets around the sine x, and there's my squared. So now and then I got the rest of it in there as well. So just to show you, there's plus sine x, and then minus 2. Now the next important thing is to change my window settings. So let's have a look. We're supposed to do this thing from 0 to 2 pi. So I'm going to change my x maximum to 2 pi. I'm going to use this pi button here. It's nice and exact. What would be a good scalar for this? It really doesn't matter. Maybe something like pi divided by 2. That might be a nice scalar. Okay, it doesn't have to be that fancy. And then if we're just looking for x-intercepts, why don't we just do something like -5 for a minimum and +5 for a maximum, and we'll make that a scalar of 1. Now that should give me a decent graph. So I'm going to hit graph. Okay, here it comes. And remember, I'm looking for the x-intercepts. So I see there is 1, 2, and that's it. So I'm looking for these 2 points exactly what they are. So I'm going to go second trace. Pull up the 0 function, move my cursor on the left side, so it's going to work its way across here until it's on the left side of that first x-intercept. There we go, that looks good. Hit enter. Then bring it to the right until we're past the x-intercept, and then hit enter one more time. And there's one of my solutions. It looks like I could round that up to 0.9. And I'm going to find the other one doing exactly the same thing. So just work my cursor over there. So there, that's pretty good on the left side. And then on the right side. Okay. And we'll hit enter one more time. And there's my other solution. It looks like 2.25. So that's it. This solution is, it's all done. I've solved my equation, and my answer is x is equal to 0.9 was our first one, and our second one was 2.25. So that looks pretty good. So we did it. All right, I'm going to do one more example. And then I think that the rest of it's just you practicing with your graphing calculator. So in this one, we're going to have the following equation, cosine of 4x equals 0. And we're going to try and find the general solution. And that means the ones that go on forever and ever. All of them, in other words. Okay, so I'm finding the general solution. You should always use as a kind of a default, if it doesn't specify, then you should be automatically working in radians. Okay? Degrees are really best avoided. So what am I going to do here? What am I going to graph? Well, let's go ahead and just graph this function, y equals cosine, and there'll be a bracket, and then we'll have 4x, close the bracket. Why don't we just go ahead and graph that? And so I'm going to pull up my graphing calculator, and I'm looking for general solutions here. So let's see, what are we going to do for the domain? Well, let's clear out this old one here. Let's get our function in there, cosine of 4x. Okay, that looks pretty good, close brackets. I know I'm in radians, so I'm happy with that, but what about the window? You know, I could do something like 0 to the 2 pi here, and just go with this and have a quick look at the graph. I might want to tweak that though. Yeah, see, I knew we're going to get a lot of graphs happening here, because remember, this compresses the graph into a quarter of its normal period. So that's why we're getting so many graphs here. Might be a better idea to stretch that out a bit. So I'm going to go back to this, and I'm happy with starting at 0, but why don't we just do something like, let's go with maybe pi by 2. You know, that's just, you know, it's a quarter of the distance that the graph normally has, and that way I can really have a little close look at it, and, you know, it's not working in such a confined little space. Okay, so that looks a little bit better, and I'm looking to find these x-intercepts. Well, let's go ahead and find them. So second trace, zeros as they're called. We'll work our way to the left side here. Left boundary. There we are, we're above, so enter, and a little bit to the right side, a little bit below, and then enter twice. So there's one of our solutions, and it's 0.39. Okay, so mental note of that while I find the second one. So left boundary again. Okay, so there we are, that's good enough. Enter. We'll go shooting past it now with the right side. Okay, that looks good. Enter twice. And we've got 1.18. All right, that's good enough. I don't think I'll need the calculator anymore. So let me just write down what we got. We got 0.39, and we got 1.18. Now we're looking for general solutions, so I got to go plus multiples of the period. Now remember, the period got tweaked here. The normal period would have been 2 pi for a cosine graph, but now it's a quarter of that, right? It's this reciprocal of that 4. So the actual period is pi by 2. So we want multiples of pi by 2. And we can put in the little disclaimer that n is an integer. We'll use the funny looking z here. All right, well there you have it. This is my solution right here, my general solution. That's all of them. And we did it with the graphing calculator. So I'm going to stop there, and we'll talk to you later.